Thank you for studying enough. Howdy, folks. Little bit more different angle I want to take here. Not so much there's a couple of technical angles to it, of course. There is different technical stuff here, but so my first presentation. I hope you get time to read it, and read some more of the details there. But I'll talk about things that could be improved in a particular file. But why would you even start looking at that file? You don't. Too many customers do not know what their important files are or what the function of their important file is, the main access patterns. Let's see if that works. So I like to, so how do you approach it then? Is then you have to approach it like, I cannot tune all the files. I need to figure out what is the important file to me. So you have to, might as well focus on like a top 10 list of files. And it's going to be a whack-a-mole game. If you did manage to find a really bad file and you tune it, disappears from the list and something else will pop up as the next top 10 game. So we have to acknowledge that we just cannot tune all the files perfectly all the time. We cannot make all the programs behave perfectly all the time, but maybe there's just this one program that is really stupid, and we can fix that. But we don't know why we would even start looking at that. So what I'm going to do is a very silly mechanism to find out what a hot file is. Does anybody here have a tool to find hot files? They existed. I'll get to that slide. So we need to know which top 10 files or which top 50 files, pick a number, any number, are the busy ones, because, and by extension, we really also would like to know which programs use those busy files. There's an interaction going. There used to be some tools like DecPS and PAUSE. They may or may not be available in various versions. Nobody seems to have them. Not the customers like that called in on. There's a ton of information that you can find with Analyze That System with the XFC extension, lock, and the RMS extensions. RMS extension is a flavor of the lock extension, essentially, showing some level of hot files. But the method I like to suggest to you, and what I choose for this presentation, is it's perhaps a silly sounding one, show memory / cache. And it's show memory / cache is was based on the XFC data, and you can then ask it to do top QIO is the one I'd like to take. You can specify a volume. You can even put a star there, but it gets excited if you put too much stuff. I prefer to have a little loop around your critical disks, so to speak, and then just what are my data disks. And we're going to use that data to find the hottest file and then see if we can do anything about those hot files. So show memory cache is in a window into XFC. All the RMS I/O goes through the XFC. Well, you could set file to bypass. But if you had done that, you are aware of the application. Some people rightly avoid a file from polluting the XFC cache and say there's no point in trying to cache this. I can do a better job. It's fine. I focus on the reads and not the writes, because the writes are typically real work. It's hard. If you store a record, it has to be stored. There has to be a write happening, right? But if I'm doing too many reads to be ready for that write, I can tune it, hopefully. But you can still try to get the writes lesser, for example, by using large buffers. So maybe instead of writing once every 5 records, you can write once every 50 records. There is tuning possible for writes, but less so. In RMS index files, in concurrent environments, we typically force a write for every activity to have resilience. So You know what show memory slash cache does, I think most of you, for virtual reads, for file reads, logical physical reads, it doesn't do anything. It counts a hit when the requested block is found in a XFC cache line, and it fills the process buffer that RMS requested from memory and doesn't do any disk I/O. If the block is not found, we label that a miss, and the memory line is allocated, and a read is done, and then transferred to the process. Show memory slash cache information is per node. So if we're going to use this, we need to run scripts on every single node. It accumulates as long as the file remains open by some process, any process. So this is a little gotcha. If a file gets opened and closed all the time, then the data could disappear. That is such a shame that I actually advise some customers to write, not just for missing these counters, but in general, it's a shame that you walk away from valid cache lines and then re-establish them later. For some customers, I've given them tools to just keep 50 files open all the time. Why not? So it's just a tiny, you have a 20-line program that reads a file of files, and it opens those files shared and allow access. That way also you can avoid somebody accidentally opening it, allowing no access, blocking the service. It just keeps all the buffers ready. Why not? Keeps the RMS buffers ready if you've got global buffers on them. XFC is great. XFC is cluster aware, but it's only defensive and not cooperative. And with defensive, what I mean is that it says, oh, somebody else is using that file also. My data might no longer be valid. Let's get out of there. So the big gotcha is that the XFC cache is cleared when the other nodes writes, and then our observations become less predictable. But the reads are going to happen anyway, just moments later. They don't accumulate as well. Well, the workaround for the XFC gotchas, of course, in general, this is nothing to do with RMS tuning, is don't do the I/O. Cache the data before it gets read, right? Use the RMS local buffers and global buffers to avoid those reads in the first place, and let our XFC just deal with your log files and all the smaller stuff that you cannot tweak by hand. XFC is just so wonderful in just caching everything. All right. Focus your activities on certain files. Yeah, that's easy said done. This is more on the XFC tuning, and some customers may be able to, let's say, run RDB and batch on one node and keep those files open there all the time and not fight with another node. You might be able to run your HR application on one node and your finance application on another node. Yes, there will be some files shared between those applications, but at least the dominant files will have their own environment. This is typically not how people use clusters. They spread them out, everything everywhere, because that's so easy. But it helps. So if no, and this is customer-based input, if no logical separation can be found, then maybe combining the nodes might be better than splitting. One customer I worked with, they came from four ES45s, and what they do, they went to the alpha emulator, and how did they set it up? As 4 nodes, mimicking those 4 ES45s, right? Easy peasy, and all your scripts are the same. But they would be much better off with 2 times 8 than 4 times 4. Easy peasy. All right. Another tuning angle on RMS, and let's see if I can fit this into 20 minutes. The XFC again, the cache lines are always 16 blocks. What I told you earlier, if you went to the presentation, the cluster size is not important. Here's where the cluster size is going to become slightly important. This is minor tweaking, but I kind of like it. The RMS bucket sizes, you could pick any number from 1 to 63, but we did find and established and proven with a couple of tests, if you pick nice even numbers that divide in nicely with the cache line, you have a slight performance benefit because the XFC doesn't have to pull data from two buffers, it can stick to one buffer. So if you pick 2, 4, 8, 16, 32 for your bucket size, if you have no other compelling reason to pick a bucket size, if you calculate that 17 is the ideal bucket size, go for it, right? Who would do that anyway? But I would say if you calculate 17, pick 24. 24 doesn't divide into 16, but at least you get one full and one half cache line. And if you read the next block, it will work out anyway. You see where I'm getting at with the divide into 16? Slightly unfortunate, RMS maximum bucket size is 63 and not 64. That would have been nice. So I sometimes pick 48, but I never really. I think 63 is still better than 48, even though the XFC interaction is not optimal. But one thing from the first discussion was RMS starts the first bucket after the overhead blocks. So it's independent of that cluster size. So now you have all the intentions in the world to make your bucket size be 16, right? But you start at block 3. So it's never going to divide up anymore. The trick there is to use areas that are defined. That is an option within RMS files. Don't know what you know them, but you can define areas in RMS index file where certain kind of information go. The index for an alternate key, the data for an alternate key, the main data. Most important part is of course the main data. The main data is put first after that overhead piece. So as long as we make the main data not be in area 0 by putting some index in area 0 and putting the main data in area 1, now I have the potential to be aligned, and I can be actually aligned because RMS will start every area on a cluster size boundary. So now, if my clusters match the 16 and the buckets match the 16 or multiples thereof, everything starts to align. A little bit far-fetched, but it does work. And cluster size used to be that literally that odd number. They always were odd, like 151 and then 103 based on the disk size. Nowadays, you just pick a big number, 1024, 512, or whatever number is appropriate for you, for your data disk, for those where you're going to have 200 files that each are many megabytes big. So the roundup loss at the end of the file for a big cluster, what do you care about? If your cluster is to be half a megabyte, or like if your files are 8,000 megabytes, right? It's no loss. If you have thousands of log files, tiny log files, you don't want the 1,000 log cluster size. But for your data disks, go that route. So that's kind of a cute thing, I think. But it's a low-level tweak, but at some point everything helps. All right, back to the real core is that how to use that glow memory, show memory / cache. So this is the output from it. You've seen that before on this file. So we see how many pages were allocated. We see how many, of course, actual data from customer, and how distinct files can be. Where here's a file with only 8 pages. But look at the at a nice hit rate, 95% with just 8 pages of memory, it's minimum. Another file on the same node, on the same drive, had 0 pages and 0 effectiveness, but it was hit quite a bit of times. But that file was constantly accessed from a different cluster member also, so we get a slightly distorted picture. So what I then did. So this already gives me the top 10 files in a naked fashion. So now you have to go and look for the big numbers and how big really are they. But if we then combine this with a script, and I need to figure out a way how to get that script with this presentation for you, of course, by the time this presentation comes available. I use Perl for that kind of work because I'm going to do text manipulation. But if you see the script, you can pick your own language to replicate the same thing. I'm going to write a script to create a summary of those hot files, and I'd like you to run it monthly or something. And I actually see people running it daily, and I'm seeing people running it daily twice a day. So I say show memory slash cache at 9 o'clock and at 4 o'clock. The main window, main predict for many sites. Other people have busyness all year, all day, everywhere around. But if I did that, then I can subtract the data from 4 o'clock, the data from 9 o'clock, from the data from 4 o'clock, and I can see how much activity I have in that busy window, which is also probably where the files stay open all the time anyway, right? So now I can calculate on a per day, per file basis how busy they were. This allows me to see which are the big files, and then my next step will be to set up RMS monitoring for those files and to understand how they're being used. And Duncan mentioned how he went all in on that subject. So, but the RMS monitoring definitely doesn't know which file is busy. The XFC monitoring also doesn't know file names beforehand. So we have to sort of work together to get my list of files. And it's all dynamic and based on the disk at that point. All right. The second level on finding your busy files is the RMS statistics. I don't think many people use RMS statistics much. And I'm going to go back again to a program that I offer to you, RMS stats. You set RMS statistics with set files for statistics or in the FDL file, or you can set it on a program level with XF item. Those are collected in a shared memory section, 1 page per file per node, and we count only the successful operations, which can be quite deceiving. You might see that you did 0 gets to a file, but you see 10,000 reads because none of the gets were successful. Could happen. How do you report the RMS statistics? So I'm going to use XFC statistics to find which are the important files to watch. I'm going to use RMS statistics to see what they are doing. How do you report them though? Well, I could use monitor RMS/item. Anybody ever done that? So you get 1 page for cache, 1 page for activity, and it floats and it shoots around. You cannot make a logical conclusion out of that, in my humble opinion. So when I was doing RMS engineering, I needed that data, and I started out with analyze a system. I added the show process RMS equals FSB, the file statistics block, to format all the bytes from the statistics block. And then I wrote using essentially the same code, wrote a tool to present it at the user level basis, showing all the activities in the RMS terms. The last session of the day anyway, but we have to. Yes. So here's the RMS statistics, and so this is my version. You could have used SDA and show RMS/FSB to get the same data. I like my tool better. That's me. RMS statistics output. If you ask that, it will show you. This is the verbose version. The simple version is only the top line. I have an artificial number IOs per operation. I'll explain that. I did so many operations on the file, which is a combination of gets, puts, all of them counted together. I did so many lock operations. I did so many local my local buffer effectiveness, my global buffer effectiveness, and how long did I collect the data for? 6.3 hours, which I think is 20,000 seconds. We picked the 20,000 second window for that. Here you see how RMS buffering works. You see how we first go in the local cache files, and if we find we see if it's there, that's number 1. If we find it in there and we have no global buffers, then we end up with the number of reads being the number of accesses minus the number of hits. if we are doing global buffers, we go one step further down. So if the number of misses in the local cache, we start to try in the global cache. And those that are not satisfied in the global cache will be satisfied by reading into the global cache. So the number, the reads into the global buffer are the starting point, how many actual reads we requested, minus the local cache, minus the hits there, and you find out the final number. You see lots of buffering going on. You see millions of gets happening to the program. And what was the odd part? Record logs. Every get has a record log associated with it. So we want to be, if you can tune that away. And but mostly what I saw in this particular file was when you realize what is happening in 6 hours, I'm doing 100 million gets in 6 hours. So I'm actually doing almost 5,000 gets per second all day, every day, is constantly. I was doing 33,000 logs per second, which is essentially half of the log capacity of that server, potentially. How many logs per second can a good server do these days?
I can say over 100,000.
Over 100,000, but not 500,000.
No.
It's a distinct number, so you can run out of log capacity. It was actually a 50 megabyte file with 100K records only. 100K records in that file were read 100 million times. So they actually read that whole file 1,000 times over. This got to be a stupid application. It's got to be. Why would you do that? You could have, I forget what the main reason, basically it was the a double table matching. They had a driver table and a lookup table, and they picked the wrong one for the driver. So they looked the table where you said, now we need to know what the customer name is, then they scanned all the customers again. The name almost implied it. Or did I remove the name carefully? Yeah, it was like it was called XREF. So it was a cross-reference file, but used the wrong way. You should just read all your customers and look up the individual records for that customer. Now you have one scan to the file and 1,000 lookups. But instead they did 1,000 lookups and 1,000 scans. Silly stuff. But how would you know? You need to get somewhere. All right. So let's not. So when I use, sorry. So I use the XFC statistics mostly just to have a starting point in which hot files to look at. The actual tuning came from the RMS statistics. So the RMS statistics, this is how you could run it. Now you get a per file chunk of data. I don't have the brain power to map all those chunks of data and see what they mean. So again, I'm going to subtract the data. Well, I used I clear the data before at 9 o'clock, then I read it at 4 o'clock, so I knew at least what happened in that window that I picked. And then I want to see what is relevant data. So another Perl script that I use for it, but you can make your own data out of it, and you can end up with a file like this. I have logs sorted by top 10. I cut it down to 5 just for visibility. And now I got something to work with. So now I see I have one file, and unfortunately this was a fixed format font when I submitted it. It turned into a flexible font, sorry. The columns don't line up well, but you see the hottest file according to XFC also had the hottest logs by a factor of 10. So which file should I focus on tuning, right? Clearly that top file. And in their case, file number 20 was about 100 times less than the top file. Do I need to worry about any more than those top 20 files? No, because the other guys just have no significant influence yet. But then I get to see how many logs, how many operations, how much time I took the samples for, and from which node it was coming from. So here's that file that didn't have any XFC hits because it was hit by all the nodes all the time. But the RMS hits we still figured out it was a hot file, and we put it in the RMS statistics gathering. So once a file is in the list, just keep on monitoring until it drops down to the bottom. In fact, so that particular report shows it by logs first, because I think logs is your best indicator of busyness. Then I also sorted by IOs and operation, and the header is gone here, but that's really a shame that the header is gone. This file had only 5,000 operations, but it had 20,000 IOs per operation going on. So it's one of those duplicate chains. And so that should be, that's worrisome. Now, other files, the lineup is so, I'm sorry about that. I don't have my columns ready. So there was only 2 operations, but they took, so this was the highest number of operations per activity, but it was only 2 of them, so I don't care again. But others that had 500 operations, IOs per operation, and had a bunch of them, it was important. So you have to slice and dice your data carefully to find out which is really important. Then you should look at which file was important on a particular node, but you may also want to add up all the nodes together and say cluster-wide, how important was the file? And then the script also reported the cluster-wide files with low activity. It's like, why do we bother to have RMS statistics on those files? Just get them out of the picture, because they're good now. So this gave us right away a nice starting point of what to look at, and I could go back into those RMS stats to see what they were doing, and then discuss with the customer. I think you're doing 1,000 gets per update. Is that what you expect, or is that a surprise to you? And often was a surprise to them. So I like to see IOs per operation as, if you're doing a put, you expect a write. So my concept of IOs per operation was IOs that are not avoidable. So if I got 5 keys on a file and I do a put, I expect 5 writes. So the IOs per operation was more, what is the excess IO per operation that's happening? And what you can find then, and these are the things from the other presentation. If you got duplicate keychains and you do insert in those, you can get hundreds of reads before a write. If you have deleted key ranges, who asked the question the prior, also, you can traverse a lot of empty buckets because you find something before you find something to do, and and that's terrible. But as long as you don't become a hot file, don't worry about it and focus on those hot files again. That's the difficult. But being a geek, VMS geek, I can't help myself. If I see a file doing 1,000 IOs before it does any work, I got to fix that, whether it's important or not. But that's me. That's all in the tuning preparation. But with that data now, you have, as you're collecting your daily hot files and RMS tests, you can go one step further. Because now I have data from every day showing the hot files, and now I can generate a CSV file saying, for my 20 hot files, these were the log counts in the window on a given day. So now I can see a file being converted, or no, I can see the weekends, obviously. The weekends are low. I can see a file getting worse and worse over time, but once I convert it, it gets good again. I can see potentially it is time to convert the file because the IOs are getting out of hand. Or this file is popping up. I never heard about it before. Why is it showing up in my list now? Why is it turning red, so to speak? The turning red is just a simple Excel function, right? The highlight color base. And this gets you out of, if you tell your customer you got to watch your hot files all day, every day, anything going to happen. And they're going to look the same every day. And then you don't see the minimal changes. But this can give you a picture at the end of the month. And then, yes, you can make it a rule that at the end of the month, somebody's going to look at the file activity and decide something is going wrong or we're doing fine. The converts didn't happen or something like that. I think that's useful. Maybe you think it's useful too. Let's skip this for now. Some tuning advice. The bucket logs, the record log. I talked about it before, and the no query log is a very important option, but requires program changes to get rid of my log activity. The global buffer logs, it's all in the slides. I put some extra words in there for you to read. I create an extra tool called tune check, which gives a nice list of usual problems with files, like it hasn't been converted in 5 years, or there's duplicate key change and a top 10 of the duplicate keys, and if there is a skip list of data in there, I think it's useful. So here's the example of the tune check output. You've been using it also at times, right? So it reads the file directly, so and non-interlocked. So yeah, it could be wrong. I've never seen it go wrong. On that subject, and I'll don't know how to communicate it to you. There's a slide that I didn't get to produce in the previous presentation. There was a commercial tool called Select from EGH Enterprise. You probably never heard about it. Okay? You heard about it? Beautiful. The company is going out of business, and they donated the tool to the world. They ported it to x64. If you just want to, in your presentation of a slide for it, just counting records, let's say search/log, right? That's the right way to count records. It's one way to count records. Convert would be a way to count records. If search an index file took 30 seconds, select would take 2 seconds. How can that be? All the RMS, analyze as RMS would take 28 seconds. Convert would take 26 seconds. Select would take 2 seconds. And you've experienced with it. It's wonderful. How can that be? It reads chunks of data outside of RMS. It doesn't do any change mode to exec, doesn't do any change mode to kernel, doesn't do any locking. It knows how the RMS structure looks like, and it knows it hasn't changed in 30 years. It just keeps on reading, and it has the name implies that you can select records. So in my case, it was the old Express scripts, which is picked up. They couldn't live without select. They had to select records from their index file on the fly before doing their converts and stuff. They couldn't run their business on RMS because RMS couldn't deliver the data quickly enough. There was none of hours in the day to read all their data. And with select, they could go 10 times as fast. Freely available. I'll try to get it into, I think I made a link in the other presentation where you can find it on the Git. Executables and sources. Wonderful little tool. We'll see how it goes. RMS tune, back to RMS tune. What does it say? Well, it gives you a top line. This is when you ran it. This is the allocation bucket size. I'll give you a count of actually my RMS. This tool gives it 9 seconds. It's not as good as select, but quicker than converted. Well, for the test I did. it tells you the basic characteristics, how big was the longest record, what is the average data size that actually after compression that you actually used. And then it said, it tries to give with a 4-letter acronym something that might have gone wrong in the file. It says, skip. There was 173 empty data buckets before this primary key. Maybe it's time to convert the file to get rid of those empty buckets, right? Maybe just. And you got to wonder again, why would, if those are empty, something special happening in that point in the file? It means that something's truly wrong. It will reappear. Next week, there will again be 100 empty buckets. And you got to do something about it. Skip buckets. There was so many empty buckets out of so many buckets. Completely empty. So it turns out that there was 173 in empty buckets in one chunk, but there was other chunks with 5 empty buckets and 12 empty buckets and so on. RRVs, out of the 10,000 records, out of the 100,000 records, 18,000 had been moved somewhere else. Probably an indication to convert the file again, right? Secondary index data records, that's a duplicate key chain. On this key, I found so many duplicates for which I need 20 buckets to store them in. So I need 20 read IOs to find the next spot to write for this value. But that value looks relatively distinct, but there was a lot of them anyway. And you can have a top 10 list of values that are hurting you. So we need to do something about that bucket. And it finds that data in no time, really. Because it's not doing RMS IO, it's just doing block IO. All right. FDL tuning, we won't go there now. Live directories, another RMS tuning thing that can hurt tremendously. Conclusion slide. I don't know why people are not doing this all day, every day anyway, but someone has to review RMS stats, XFC stats regularly, daily is not going to happen. That's fine. Although you might want to have a cursory glance at something pop up, then someone in your company needs to understand RMS, please. That's my other presentation again. Sorry to go there. It's like, if this was an Oracle database, you would have certified Oracle engineers working on it. Why don't you have a certified RMS engineer working on it? Somebody with a basic skill level. Someone, and this could be a very junior person, someone should work down the list of hot files every week. Say, you know, your mission is Monday morning, you go over the report and see if anything popped up. And it's fine if you say nothing popped up. But you cannot just ignore it for years and years and years. I like my tune check, of course. I like to interpret those stats. You got to build up a history. Was this always a hot file? Has it become a hot file? Now I can learn when to do my converse. I have to start understand the usage pattern by application and tune for that usage pattern. And you know, stretch goal ain't going to happen. How can we make that usage pattern better? I can convert files and change FDLs, but I cannot get my hands on the COBOL application, can I now? Sometimes you can. And I think one of the critical items is document what you find there. If you have to call support, you should be able to give them a 2-page summary saying, these are the critical files in my environment. This is how they're being used. Why do I have to, you know, find the right guy in your operations that knows all this stuff? It should be documented, right? That's what I want you to do, document those damn files. That's my talk.